Okay, the purpose of this model is to explain how to use a lookup table block to get two different effects from the same random variable. So in this model, we have an earthquake occurring, but we think that we have a different probability of getting damage depending on whether or not the building in question adhered to our building codes. So there's, again, multiple ways to do anything in ExtendSim. In this one, we're going to be generating a probability of damage using a linear interpolation, so a piecewise linear model. The easiest way to do that is using a lookup table block. So I drag up my lookup table block over, I hook that up to my earthquake magnitude. Now I need to set up the values inside this table. So we need to check to see what the incoming values are. Those incoming values are between 4 and 8. So that's what can be generated coming out of this random variable. We have to make sure that that matches up to the inputs that we get into the lookup table, because we're translating those, again, using a piecewise linear function into effects. So we need to set up our table between 4 and 8. So this is the translation into the actual earthquake probabilities. So this gives us the probabilities . So notice here that we have an excessive number of rows inside the table. And also we only have one output column where we want two output columns. So we're going to hit the minus button, and that allows us to resize the table. We wanted a total of 5 rows in the table, and we want 3 data columns. So now we can put in our input and output values, but it's kind of handy if we can see the column labels so we make sure we're not getting confused. So the input was the magnitude. Then the first column we're going to say is with our building codes. And then second is without the building codes. Okay, so we open this up and we now see from the dialog box that we have with and without codes here. We can set up then, if we have a magnitude 4, that's going to set up the amount of damage. Let's say that's fairly small here. There's some probability of damage, but it's not a lot. Now, without the building codes, we're going to have a higher probability of damage. And similarly, we're going to set up the rest of our magnitudes of damage so that without the code, we have a much higher probability of damage happening. Okay, so let's make sure we have something that looks like what we're intending. So we generate the plots. Now notice this goes up stepwise, which is the default behavior for this block. So that's not really what we want. We don't want to generate exactly, 0.7, 0.8 or whatever. We want to generate something that looks more continuous. So we need to go back to the dialog, and then we need to choose an interpolated value. So if we plot that, now we see that we have the intention, which is the second output, the red line here, that gives us a much higher probability of damage than if we actually had adhered to the building codes. And so now what remains is to actually translate that damage into an effect, probabilistic effect in our model. If we ran the model now, we'd see nothing is, or we're not going to see an effect between the two, because essentially we have the same probability distribution in there that has whatever the default probability is in there. So we need to actually funnel a different value for the probabilities to with and without the codes. So we have our with codes named connection. And so I'm going to duplicate that. And then make sure that that goes into the section that I think is going to be with the codes, which is this. And then, so with codes, and then I have without codes. So I just want to make sure I'm setting up the properties of the item is passing through the block correctly. So no codes is going to pass one way, and that's going to incur more damage. So what I'm sending into the property here is that, notice that I'm sending the value 0 or 1. So the value that property is going to be damaged, going to send 0 or 1 through here. That 0 or 1 is being generated by my binomial random variable by setting the probability here is being set externally, so it doesn't matter what's in this dialog box. The number of coin flips I'm doing here is 1, so that produces only the value 0 or 1. Now if I run, I'll see that we had a we can see the number of throughput on each of these damage assessments. So in 556 of the cases, we got no damage. And then otherwise, in the other cases, we got damage. So this ends the tutorial.